So question 15, in a game of cricket, a player hits the ball, which take the path P. Air resistance acting on the ball as it traveled through the air. If there was no air resistance, then the path followed will be Q. We assume that the projectile is having, in a projectile motion, we assume there is no air resistance, but practically there will be air resistance. And due to air resistance, the time of the flight will decrease, the vertical component will also decrease, and it will have a smaller deceleration. Draw free body force diagram for the bat when its position marked at X. Sorry, for a ball, not the bat. Draw free body force diagram for the ball when its position marked means what are the forces acting on the ball? Look, first thing, there will be a free body force diagram represent all the forces acting on the object. So first there will be a weight of this ball which is acting downward. The second one, air resistance. Air resistance always try to oppose the motion. So this one is the direction of the motion, as you can see, like the trajectory, the path is shown to you. So if this is the direction of the motion, air resistance always try to oppose the motion. So this will be the drag, or we can also say air resistance. Next question, explain the differences between the path P and Q. So what are the differences between the path P and Q? For path P, you can see there's a shorter range as compared to that of Q. Range is smaller. What is the reason why the range is smaller? Because the air distance opposes the motion, so horizontal component decreases. So for range of P is shorter than Q. What is the reason? Because the air distance opposes the motion, so it causes deceleration to the horizontal component, or reduce or decrease the horizontal component. That's why the range will be shorter. And for P, you can see the maximum height reach is lower as well. What is the reason for that? Like you can see this vertical height reached by P is smaller than Q. Because there's an air resistance, so there will be more downward force. As there will be a like weight is already acting downward, and there's a drag or air resistance is there, so there will be component of air resistance that is also acting downward. So there will be greater downward force. So it reduces the velocity more, or it will have a greater deceleration. No, there should not be any arrow representing, because we free body force diagram represent all the forces acting on the object. So when the bat hits the ball, then there is a force from the bat, there is a force by the ball, and there is a weight acting downward. But at point X, we have to make a free body force diagram at X. So there is a weight acting downward, and the drag or air resistance try to oppose the motion. So you should not draw any force forward. That will be wrong. That forward force only act initially when the bat hits the ball. But when the ball is moving through the air, the weight and the air resistance are the only forces which are acting. Otherwise, if there was any forward force on the ball when it is not in contact with the bat, means the ball should continue to accelerate. But the ball is not accelerating, the ball is decelerating. So two differences, one is the range, another one is the height. Why range is smaller? Because the horizontal component decreases, lower horizontal component. And why maximum height decrease? Because there is a greater downward force which increases the acceleration or reduce the vertical component. In part B, the ball was given the initial velocity of 35, at an angle of 25 to horizontal. So example, it is launched at a speed of 35. and the angle with the horizontal is 25 degrees. The horizontal distance from player to the boundary is 85 meter. So the boundary is 85 meter from the player. The player scores 6 runs if the ball lands beyond the boundary. Like if this ball, when the player hits, if it crosses the boundary directly, like land beyond the boundary, it will be 6. If it land before the boundary, it will be 4. So ignoring the air resistance, we have to determine whether the 6 runs will be scored or ignored any effect of air resistance. So mainly what we'll find, we want to find the range of this. If its range is more than 85, it means that it will score 6. If it is less than 85, means it will not score a 6. So first part we will find is horizontal. Whenever a question is there related to projectile, first part you will divide into parts like find the horizontal and the vertical component. The horizontal component is given with cosine. So this will be equal to 35 cosine 25. And the vertical component will be equal to 35 sine 25. If I need the range, if I need the range of the projectile, range is equals to horizontal component, like it will be 35 cosine 25 into the 35 cosine 25 into total time of the flight, like how much time it will take to fly, like cross this total time of the flight, going up and then coming down. So we have this 35 cosine 25, but we don't know the time. So what we can do, how to work out the time? First, we'll find the time to reach the maximum height, and this total time will be twice. Like first, I find how much time it will take to reach the maximum height, same time it will take to come down. So total time will be 2t or twice of this. So first, we have to find time to reach the maximum height. So when it reach a maximum height, there's a vertical component is there of the motion. The vertical component is equals to 35 sine 25. And the vertical component at the maximum height is 0. And the deceleration is due to gravity, which is minus 9.81. So we'll use a formula V is equals to U plus AT, where V is the final vertical component 0. U is the initial component, initial vertical component, that is 35 sine 25. Then plus acceleration is due to gravity, which is minus 9.81. So that's why I wrote negative. Or I can, instead of this, I can directly write plus minus, it will be minus. So I can write here minus 9.8 into t. When we simplify, this will move like negative 9.81 t, it will move other side, so it will be positive 9.81 t is equals to 35 sine 25. And if I need time to reach the maximum height, so it will be 35 sine 25 divided by 9.81. So how much time it will take to reach the maximum height? What's the answer? 35 sine 25 divided by 9.81. So this will be 1.508. Okay. So 1.508 seconds it will take to reach the maximum height. And how much time it will take to total time of the flight? It will be twice, because we need this t. This t is actually twice. So it will be the total time of the flight 2 into 1.508, which is equals to 3.02. So we have the total time of the flight. Now we can find the range. So range is equals to horizontal component, which was 35 cosine 25 into total time, which was 3.02. When we multiply, it will be 95.80 meters. So means that this projectile will cover 95.8 meters, and to so means it will land beyond the boundary, or it will land after 85 meters. So means the player will score 6. Is it clear, this one? In question 16, the path of a projectile is shown. The projectile landed at a lower than the height from which it is launched. Assume that there is no air resistance acting on the projectile. Which is the correct statement for this? At maximum height, the horizontal velocity is minimum. That is totally wrong, because horizontal component of the velocity does not change at all until unless they mention there is a air resistance. At maximum height, the vertical component velocity is maximum. That's also wrong. Vertical velocity is minimum. Like it is, the vertical velocity is maximum in the beginning, but it slow down, and eventually at maximum height, the vertical is 0. Initial horizontal velocity is equals to final horizontal. That's true, because there is no air resistance to oppose the motion. That's why the initial, like if I any point horizontal component, if this was 3 here, it will remain 3 throughout. It does not change. Initial vertical velocity is equals to final. This statement can be true if the projectile reached the same starting position, like same height, same level. So last statement can be true. If this was a question, then the last statement can be true. Like if this was a figure, then this last statement will be true, that the initial vertical velocity is equals to final vertical, but in negative, like opposite. If this was initial vertical is say plus 10, the final vertical will be minus 10. Directions will be opposite, but the magnitude will be same if it land to same height, like same level, not the height, same level. So in this case, C will be the right answer. So this question, while playing golf, the player use different golf clubs depending on the distance the ball need to travel. Different golf club produce different launch angles. A golf club strike the ball leaves at an angle of 26. Calculate the horizontal distance, so we need the range. So how to do this question? This is a similar question we did just now about the cricket ball. So we have the launching speed 35, and we have the angle 26. So this will have two components, horizontal and vertical. Horizontal will be 35 cosine 26, and vertical will be 35 sine 26. And this will be the trajectory followed. So what we'll do, the same, because to get the range is horizontal component multiplied by total time of the flight. So first we'll find the time to reach the maximum height, and then the total time will be double of that. Like this t will be equals to total twice of the time to reach the maximum height. And how to get the time for maximum height? U is equals to v is equals to u plus at, where u is the vertical component here. This will be v will be 0 here, acceleration due to gravity, and we'll work out the time. Then we twice, so we get the total time, multiply to get the range. So same question, just you have to substitute the values. The path of a golf ball is shown below. Add a diagram to show the path of a ball would have taken if it left the golf club same speed but an angle of 42. Here angle 26 is there, but now it is, when we increase the angle till it reaches 45, it will be a maximum range. So when we increase the angle, the range increase till 45. After 45 again it start to decrease. So it's like change from 26 to 42. So it is near to 45. So the range will also, range and the maximum height will increase. Draw continuous line, not the dotted line. Or you can, if you want to draw dotted, so fine. The next part, the actual distance traveled by the ball is affected by air resistance and the upward force caused by the spin of the ball as it moves through the air. How each of the forces would have affect the distance in A. Like the distance or range we calculated in A1, how the air resistance will affect air resistance. It will decrease the time for the flight, or it will reduce the horizontal component. So the range will also decrease. And if there is an upward force due to the spin, if upward force is there, so there will be greater upward force to increase the time of the flight. As a result, the range will also increase. Like the two things they mentioned, if there was air resistance will try to oppose the motion. So as a result, that it will cover a shorter distance. If there's an greater upward force, so it will rise to a greater height. It will take longer time to reach the ground. So the range will also increase. So this was question 17 and the assignment projectile.